There is a strange pattern running through the UFO and UAP mystery. It does not appear in every case. It does not prove anything by itself, but it keeps returning. Compasses spinning, radios failing, aircraft instruments behaving strangely, vehicles stalling, lights flickering, radar detecting something the eye cannot explain, infrared sensors recording heat signatures that raise more questions than answers, and in some cases witnesses describing glowing objects that appear less like machines and more like energy in the sky. For decades, people have asked whether UFOs are craft. But what if some UAP reports are not about objects in the traditional sense? What if some are electromagnetic events? What if the phenomena is not only being seen, but measured through the very forces that shape light, radar, radio, heat, magnetism, and electrical interference? Tonight we're not asking whether electromagnetic theories prove aliens. They do not. We're asking something more careful. Can electromagnetism help explain why some UAPs are seen, tracked, misunderstood, or remain unresolved? Welcome to UFO to UAP Explained. I'm your host Matt Tones, and today we investigate UAPs and electromagnetic theories, plasma, sensor interference, and the science behind UFO encounters. Today's episode sponsor is growmypod.com, a growth intelligence platform designed to help podcasters grow their audience. Let's begin. Electromagnetism sounds complex, but in UAP research it sits at the center of almost everything. Visible light is electromagnetic radiation. Infrared is electromagnetic radiation. Radar uses electromagnetic waves. Radio communications depend on electromagnetic transmission. Satellites collect electromagnetic signals. Night vision, thermal imaging, targeting systems, and many military sensors all depend on detecting some part of the electromagnetic spectrum. So when we talk about UAP evidence, we're often talking about electromagnetic evidence. The witness sees light. The radar sends and receives signals. The infrared sensor measures thermal radiation. The camera records photons. The radio may experience interference. The compass may react to magnetic disturbances. That means the UAP question is not only what was in the sky, it is also what did the electromagnetic environment reveal. NASA's UAP independent study team argued that future UAP research requires better calibrated data, multiple measurements, and strong sensor metadata because many reports lack the information needed to determine size, speed, distance, or nature. That is a critical point. Without metadata, even a dramatic video may tell us less than we think. This is where electromagnetic theories become important, not because they give us an easy answer, but because they tell us what to measure. If a UAP case involves an alleged electromagnetic effect, then a serious investigation should ask, was there a measurable magnetic anomaly? Was radio frequency interference recorded? Did instruments fail independently? Were multiple systems affected at the same time? Was there a power fluctuation? Was the radar return consistent with a physical object, plasma, clutter, or an atmospheric interference? Was infrared data present? Was there environmental records? Were the effects localized, repeatable, and time-matched to the sighting? That is the difference between a story and an investigation. Question for you. When you hear reports of compasses spinning, radios failing, or engines cutting out during UFO encounters, do you see that as important evidence or as a detail that needs much stronger proof? Drop your answer in the comments. Now, let's break this into three categories. The first is electromagnetic detection. The second is electromagnetic interference. The third is electromagnetic explanation. Detection means how we observe UAP. Interference means how a UAP are sometimes reported to affect nearby systems. Explanation means whether some UAP could be caused by electromagnetic or plasma phenomena rather than solid craft. These are not the same thing, and mixing them together is one reason the subject becomes confusing. A radar return does not automatically mean electromagnetic interference. A glowing object does not naturally mean plasma. A vehicle failure does not automatically mean a UFO caused it, and an unusual magnetic reading does not automatically prove non-human technology. But each of these can matter if the data is collected properly. Let's begin with detection. Modern UAP research is increasingly a sensor problem. ARROW describes its mission as detecting, tracking, analyzing, and managing anomalous detections and UAP using scientific and intelligence standards. That tells us the modern government approach is no longer built around witness reports. It is built around systems: radar, infrared, optical cameras, satellite systems, signal analysis, pilot reports, military databases, air traffic records. These systems do not see the world the way we do. They translate electromagnetic signal into data. Radar does not see an object, it receives energy reflected back from something. Infrared does not see a craft, it detects heat or thermal contrast. A camera does not see truth, it captures light under specific conditions with specific limits. That is why UAP research has to be careful. A sensor can reveal something real, it can also mislead. Radar can be affected by atmospheric conditions. Infrared can exaggerate or distort apparent motion. Cameras can lose scale and distance. Satellites can capture objects without enough context. Night vision can make ordinary objects look quite extraordinary. So electromagnetic detection is powerful, but is not automatically conclusive. It needs correlation. One sensor is a clue. Two sensors are stronger. Three independent systems, time-synced and properly calibrated, begin to move a case into very serious territory. This is the heart of sensor fusion. A future UAP case becomes stronger when radar, infrared, optical tracking, radio frequency monitoring, flight data, weather records, and witness testimony all point to the same event. This is not proof of origin, but it is stronger proof that something happened. Now let's move to electromagnetic interference. This is one of the oldest and most controversial parts of UFO reporting. Across UFO history, some witnesses have claimed that close encounters affected electrical systems. Car engines stalled, headlights dimmed, radios filled with static, aircraft instruments malfunctioned, compasses behaved strangely, watches even stopped, power systems flickered. In some stories, the object departs and the systems return to normal. These accounts are dramatic because they suggest interaction, not just observation, not just lights in the sky, but a possible field effect. Something in the environment allegedly changed. The problem is that many of these cases were not measured at the time. They were reported afterward. That does not mean the witness lied. It means the evidence is usually weak by modern standards. A serious investigation would need time-stamped instrument logs, maintenance records, power system data, magnetometer readings, radio frequency recordings, flight instrumentation, environmental conditions, independent witnesses, and a clear timeline. Without that, electromagnetic interference remains interesting, but not proven. This is why modern researchers have started thinking about magnetometers and electromagnetic monitoring as part of UAP observation systems. A 2025 Galileo project paper describes adding a geomagnetic barometer station to a UAP research instrument suite because some witnesses' reports associate UAP sightings with effects such as spinning aircraft compasses or vehicle malfunctions. The goal is not to assume those claims are true. The goal is to test whether magnetic anomalies appear alongside other sensor data. That is exactly the direction UAP research needs. Not belief, measurement. Not folklore, instrumentation. Not something strange happened, but what changed? How much did it change? When did it change? Was the change local or regional? Was it recorded by more than one instrument? Can ordinary causes explain it? This is where electromagnetism becomes scientifically useful, because electromagnetic claims are testable. If a strong magnetic field is present, it can be measured. If radio interference occurs, it can be recorded. If power fluctuates, logs may show it. If radar is affected, the data can be analyzed. If thermal signatures exist, infrared can capture them. The question is whether future cases are investigated quickly enough and carefully enough. Question for you. Would you trust an electromagnetic UAP case more if it included magnetometer readings, radio frequency data, and radar correlation, even if there was no clear video? Tell me your thoughts in the comments. Now, let's dive in and talk about plasma. This is one of the most important electromagnetic theories in official UFO history. Plasma is sometimes called the fourth state of matter. It is an ionized gas, meaning it contains charged particles. Because plasma involves charged particles, it interacts with electromagnetic fields. Lightning is plasma. The auroras involve plasma processes. The sun is plasma. Some atmospheric phenomena may involve plasma-like behavior. In the UFO context, plasma theory suggests that some luminous UAP reports could involve natural or unusual atmospheric electrical phenomena rather than structured craft. This idea is not new. The UK Ministry of Defence Project Condign examined UAP reports in the UK Air Defence region and considered plasma-related explanations for some cases. The report was released after Freedom of Information efforts and became one of the most discussed official studies involving UAP and atmospheric plasma hypotheses. This matters because Project Condign did something interesting. It did not simply say people saw nothing. It considered whether some sightings might involve real phenomena that were poorly understood. That is an important distinction. A case can be real and still not be a craft. A witness can observe something genuine and still not know what it is. A sensor can detect something unusual and still not prove technology. Plasma theories offer one possible bridge between witness experience and scientific explanation. A glowing shape could be a luminous atmospheric phenomenon. A moving light could be affected by environmental conditions. A radar return could be complicated by ionized material or atmospheric effects. A person nearby might report strange sensations, visual effects, or instrument interference. But here is the caution. Plasma should not become a replacement myth. It should not be used as a magic explanation for every difficult UAP case. Not every UAP is plasma. Not every glowing object is ball lightning. Not every radar anomaly is atmospheric. A theory only works when it fits the evidence. When did the event occur? What was the weather? Was there lightning activity? Were geomagnetic conditions unusual? Was there a meteor shower? Was radar involved? Was the object structured? How long did it last? Did it move against the wind? Was it tracked by multiple systems? Did it leave physical traces? Did it show intelligent behavior? Those questions matter. Plasma may explain some cases, it may not explain others. The point is to not force a conclusion, the point is to test the theory. Now let's move into a more speculative area. Electromagnetic propulsion. This is where the conversation often becomes risky. Some people argue that UAP performance could involve advanced electromagnetic propulsion, gravity manipulation, magnetohydrodynamics, field effects, or some kind of interaction with space-time. Those ideas are fascinating, but fascination is not evidence. Arrow's historical record report stated that US government investigations had not confirmed that any UAP sighting represented off-world technology, and that Arrow had no evidence for claims of extraterrestrial reverse engineering programs. That does not mean all UAP are explained. It means we must be careful about origin claims. Electromagnetic propulsion remains a hypothesis only when applied to UAP. To take it seriously, investigators would need signatures. What would we expect to see? Strong electromagnetic fields, ionization of surrounding air, radio frequency emissions, thermal effects, interference patterns, radiation signatures, material effects, changes in surrounding plasma or atmospheric chemistry, correlated sensor anomalies. If a craft used some kind of powerful electromagnetic field, it might leave detectable traces. But might is not enough. A serious UAP investigation has to ask, were those traces actually measured? Were they measured by calibrated instruments? Were they present before and after the event? Were they localized to the object? Could known systems produce them? Could natural phenomena produce them? Could sensor error produce them? This is how we protect the subject from overclaiming. Because the moment we say electromagnetic propulsion without evidence, we move from investigation into speculation. But the moment we collect real electromagnetic data, we create a path to test the claim. Question for you: do you think electromagnetic propulsion theories are a serious scientific possibility for UAP cases, or do they move too quickly beyond the evidence? Drop your view in the comments. Now let's connect this to historical cases. Many famous UFO cases include some kind of electromagnetic language, even if the evidence varies greatly. Some involve radar, some involve lights, some involved alleged vehicle effects, some involve radiation claims, some involve communications interference, some involve instrument readings. But the important question is not whether those details sound dramatic. The question is whether they were preserved. Were original records kept? Were instruments calibrated? Were environmental conditions documented? Were witnesses interviewed immediately? Were physical sites secured? Were sensor logs saved? Were military systems involved? Were ordinary explanations tested? This is where older cases often struggle. They were investigated with the tools, attitudes, and evidence standards of their time. Sometimes the witnesses were serious. Sometimes the report was sincere. Sometimes the cases remain unresolved. But unresolved is not the same as proven. Electromagnetic theories expose the gap. They show us what should have been measured: the magnetic field, the radio environment, the radar track, the power state, the thermal signature, the optical record, the physical site, the metadata. Without those pieces, the debate becomes endless. One side says the electromagnetic effects prove something extraordinary. The other side says the evidence is too weak. Both may be reacting to the same problem. The data was never complete enough. This is one reason the future of UAP research cannot depend only on old files. Old files matter, but future cases need modern instrumentation. That means UAP observation systems should be built like scientific stations. Optical cameras, infrared cameras, radar where possible, magnetometers, radio frequency monitors, weather stations, satellite tracking, aircraft tracking, meteor data, lightning data, time synchronization, raw file preservation, open methods, independent review. The Galileo project's work on multimodal observatories reflects this direction, using integrated instruments to collect multiple kinds of data and recognize anomalies rather than relying on isolated witness accounts or single sensor clips. This is where electromagnetic theories become practical. They tell researchers what instruments to include. If witnesses report compass effects, include magnetometers. If cases involve radio interference, include RF monitoring. If objects appear as light, include optical and spectral analysis. If cases involve heat, include infrared. If radar is involved, preserve the radar data and its metadata. If the theory predicts a field effect, measure the field. That is how the subject matures. Now let's discuss what electromagnetic data could actually reveal. First, it could explain some cases: a luminous plasma event, atmospheric electrical phenomenon, satellite flare, drone, aircraft, or sensor artifact might be identified once the electromagnetic context is understood. That is a good outcome. Solving cases is not a failure. Second, it could strengthen unresolved cases. If a UAP is seen visually, tracked on radar, recorded in infrared, accompanied by local magnetic disturbance, and no ordinary explanation fits, the case becomes much harder to dismiss. Third, it could expose sensor error. If a radar return appears but no optical, infrared, magnetic, or environmental evidence supports it, investigators may focus on system behavior. Fourth, it could identify patterns. Maybe some reports cluster around geomagnetic disturbances. Maybe some correlate with storms. Maybe some occur near military training zones. Maybe some appear during satellite passes. Maybe some remain unexplained even after all those filters. That is where artificial intelligence may help, not by declaring truth, by finding correlations across large data sets. But AI only works if the data is good. Bad data produces false confidence. Missing metadata produces weak conclusions. Poor calibration produces confusion. That is why NASA's recommendation around sensor calibration, metadata, and multiple measurements is so important. Artificial intelligence cannot rescue a poorly documented sighting. It can only work with what has been collected. Now let's consider the strongest possible electromagnetic UAP case. Imagine a pilot sees a glowing object. At the same time, aircraft radar tracks it. A second aircraft records it in infrared. A ground radar also detects it. A magnetometer station records a local anomaly. Radio frequency monitoring detects unusual emissions. Weather data rules out storms. Satellite and aircraft databases rule out known traffic. The raw data is preserved. The metadata is intact. Independent analysts review the case. The result is not aliens confirmed. The result is a real event occurred. It had visual, radar, infrared, magnetic, and radio frequency components. Known explanations were tested and found insufficient. That would be a major case, not because it proves origin, but because it proves convergence, and convergence is the future of UAP evidence. One witness can be wrong, one sensor can mislead, one video can be ambiguous, but multiple independent electromagnetic measurements align in time and space are harder to ignore. That is the standard serious UAP research should pursue. Now, there is another side to this. Electromagnetic theories can also be misunderstood. They can become a way to sound scientific while avoiding evidence. A person can say frequency, vibration, energy field, quantum, or electromagnetic propulsion without providing measurable data. That is not science, that is vocabulary. Real science asks, what frequency? What field strength? What instrument measured it? What was the baseline? What was the uncertainty? Can it be repeated? Can another lab confirm it? Can ordinary causes be ruled out? This matters because the UFO field has often blurred the line between scientific language and scientific evidence. Electromagnetism is real. Plasma physics is real. Radar is real. Infrared detection is real. Magnetic fields are real. But using real words does not make every claim real. This episode is not an endorsement of every electromagnetic UFO theory. It is a call for better measurement, because if electromagnetic effects are part of the phenomenon, they should be investigated, and if they are not, then serious investigation should show that too. Question for you. Should future UAP investigations include electromagnetic monitoring as a standard, magnetometers, RF sensors, infrared, radar, and environmental data, even for civilian research? Tell me your thoughts in the comments. Now, let's return to the bigger disclosure question. If UAP are electromagnetic in a meaningful way, then secrecy becomes more complicated because electromagnetic data is often tied to military sensors. Radar capabilities are classified. Infrared systems are sensitive. Signal intelligence is classified. Satellite data may reveal collection capabilities. Even the absence of data can reveal where sensors are weak. This is one reason governments may struggle to release full UAP evidence. A video may look simple to the public, but the metadata behind it may reveal platform location, sensor type, resolution, range tracking ability, and operational context. Arrow has noted that redactions can protect sensitive military operations, platform sensor capabilities, eyewitness identities, facility locations, and sensitive military site information. That means electromagnetic evidence may be some of the best evidence and also some of the hardest to release. This creates a public trust problem. The public wants proof. The strongest proof may be classified. The government may say an event remains unresolved, but without the underlying data, the public cannot evaluate why. This is the loop UAP disclosure keeps getting trapped inside. Trust us, we studied it, it is unresolved, but we cannot show you everything. That may be understandable from a national security perspective, but it is not satisfying from a public transparency perspective. So the future may require a middle ground. Independent scientific panels with clearance, public evidence summaries, redacted but meaningful sensor metadata, standardized case quality ratings, clear explanation of what was ruled out, release of non-sensitive environmental data, and civilian sensor networks outside classified systems. That is how the electromagnetic side of UAP research could move forward without exposing sensitive defense capabilities. Now, where does this leave us? Electromagnetic theories do not solve the UAP mystery. They sharpen it. They show that the sky is not only watched by eyes, it is watched by instruments. They show that some reports may be natural atmospheric effects or events. Some may be sensor artifacts. Some may be classified human technology. Some may involve ordinary objects seen under extraordinary conditions. And some may remain genuinely unresolved. The electromagnetic framework gives us a better question. Not do you believe, but what was measured? What changed? What did multiple systems detect? What explanations were tested? What data is missing? That is the UFO to UAP transition in one sentence. From belief to measurement. From stories to signals. From claims to data. from mystery to method. And if there is something truly extraordinary in the UAP record, electromagnetism may be one of the ways we finally detect it properly. Not through one blurry video, not through one dramatic testimony, not through one unexplained radar return, but through converging evidence across the electromagnetic spectrum. Visible light, infrared, radar, radio, magnetic fields, environmental records, all pointing to the same event. That is what serious investigation demands, and that is what the next generation of UAP research must be built to collect. Final question for you. Do electromagnetic theories make UAP cases more credible, more explainable, or more uncertain? Leave your answers in the comments below. This has been UFO to UAP Explained. I am Matt Tones. If you found this episode valuable, follow the show, share it with someone interested in UFO disclosure, UAP science, radar, plasma theories, sensor fusion, ARROW, NASA, and the future of unexplained aerial phenomena. And remember, the question is not whether the unknown gives off light. The question is whether we are finally building the instruments needed to understand what that light means.